Hello everyone, my name is Nana. I go by Nana Hacks, and I'm really excited to launch this brand new project I created called GenAI Dev Onboarding Starter Kit. The whole purpose of this project was really to help developers or anyone who was curious about GenAI systems to get up and running with a hands-on experience, a tutorial, a workshop, whatever you want to call it, that can teach you how to build a RAG system and then how to evaluate it. If you're looking to get more of an intro to RAG, I have another video coming out that will dive deep into that. That's more of a pre-lab before diving into this one. But if you're ready to have a hands-on experience, then I can share the link to this Google Colab notebook in the description. And I also have a GitHub repo that you can take a look at, and it can give you some guidance on how to get started, what's inside, a full overview, and what you're going to learn and take away from this hands-on project. So definitely give it a look and star it and give me feedback. And we're going to dive right into the demo in Google Colab. So the whole purpose of this GenAI Dev Starter Kit is really to build a RAG pipeline and then be able to evaluate it. So you can see here at the top of this Colab notebook, we're going to build a Retrieval-Augmented Generation pipeline, and we're going to be using LangChain, OpenAI, Chroma DB, and Ragas. The first steps here are to set up the environment and install all the dependencies for this project. Everything in this project, like I said, is in the GitHub repo. So you should have all the files needed that this notebook will talk to, but we're going to clone the repo within this environment and start running the code. So before you begin, you will need an OpenAPI key. We have all the project files that will be installed into this environment. And a few important things to note about the different tools. LangChain is like the orchestration platform that we're using to build this system. OpenAI is specifically and strictly for the LLM, the model that we're going to use. Chroma DB is the vector database that we're going to use for this project. And Ragas is the evaluation system that we're going to use. Another thing to note is that most of these tools are used because of the easy setup and integration with LangChain. So LangChain is the foundation here that is going to make this, is what made this code pretty easy to set up using Python and Poetry for dependency management. So to set up the environment, we need to clone the project repository if you haven't already done it. I'm going to run this code and approve of code execution. Okay, great. So we can see that the repo has been cloned into our environment, and there is a check mark right here. We are good to go on executing that code. Everything went smoothly. Now we're going to change our directory to the project folder. The project folder is called GenAI Dev Onboarding Starter Kit. We also have a print statement, environment setup started. And now we know that we are in the content /GenAI Dev Onboarding Starter Kit repo. If you want to confirm, you can move over to the files in Colab, and you should see that here, GenAI Dev Onboarding Starter Kit. This is everything that is in that project that came directly from GitHub. And next, we're going to confirm we're in the correct directory before we begin installation. This is just something I like to do and keep it separate from the rest of the commands to make sure that we are in the correct place to run these different programs. And the next step is to install Poetry for managing Python dependencies. Poetry is going to take care of everything that we need for all of the dependencies that will be used, like LangChain, Ragas, Chroma, everything that we'll need for this project in order to build a RAG system. I'll run that, execute that code for installing Poetry and adding a path to this current Colab session. And take a look at the output here. Let me close these files. Retrieving poetry metadata. Welcome to poetry. This is a good sign. The next step is to install poetry dependencies, project dependencies with poetry. So I've run the installation process for poetry with this curl command, and also added it as a path for the current Colab session. And this is the output. Everything's looking good so far. Poetry was successfully installed. We are in a good spot. The next step, we're going to install the dependencies from the project using poetry. So that is another command. And this is going to read our PyProject toml file, and it installs everything, including LangChain. We'll take a look at that file in just a second. But let's go ahead and execute that code. So it's creating the virtual environment and resolving any dependencies. While I was creating this and debugging the code for hours on end, just cleaning everything up, I was running into a lot of dependency issues. There were just a lot of version compatibility issues. But eventually I got it in a good spot just for you all to make sure that it would be smooth sailing and that you wouldn't have to run into issues that I did. The output here is pretty long. And after installing everything, you see Chroma, Ragas, tokenizers, so many packages and modules that are going to be helpful for this. Then Poetry locks the file that includes these fixed versions of these dependencies that will be used. In the PyProject toml file, if I double click here, and make the screen a little bit easier. This is the list of, this is basically just general information about the project, my RAG project, the version, all of that metadata that Poetry can use, and then the list of dependencies and their versions. So this is what Poetry uses to determine which version of the dependencies that we're going to use in order to run this project and build our system. Okay, so we've already made a lot of progress. We are ready to set up our OpenAI API key. This is huge. We need access to OpenAI API in order to call the model, the LLM, to give us a response when we prompt it. And then to, on top of that, use the documents, which is what RAG is all about, is using documents that we have stored for context to shape the answer that it gives us. So the LLM is going to be working with the documents that we have in our project, and then that is what determines the answers that we get. And hopefully, when we evaluate those answers, they line up with the source of truth for the documents we've stored. So I can quickly dive into why the code was written this way. You see, there's a lot of logic here, a lot of conditional statements. The thing is that there are multiple ways to get an OpenAI API key or any API key that you want to use. If you want to use Gemini, we're using Google, so they have a really simple or easy process for setting up a Gemini API key to start using one of their models. The thing is, you could have it in your operating system environment. You could have it stored inside Google Colab, so it's available for use across many different projects, which I think is very convenient. Or if you don't have an API key at all, then we can use getPass in order to prompt a user who's running through this program to actually go and find or create an API key and then copy and paste it into here and set it up. In my case, I have a key already stored in Google Colab. So this is a pro tip for anyone who wants to make this process easier in the future, is that you go to the key here in the left nav under secrets. You can decide which keys or tokens you want to enable or give access to for that notebook. If you create your key or you have one, Then you give it the name, and then you copy and paste the value here and make sure that it's enabled. So this is the standard way to access your secret keys in Python with Google Colab. From Google Colab, import user data get secret name, and you replace secret name with OpenAI API key, Hugging Face token, whatever it is that you need to use. I'm going to go ahead and close that, and I will run this if I haven't already. I have not. Let me X out of this to give you all more space so you can see. So here I've run the code. It's checked to see in Google Colab if I have an API key already stored. And because I do, it's letting us know using Google Colab API key, and the key has been set successfully. We are good to go with the next step, which I'm really excited about, is data processing and embedding using LangChain. Here are the big things that we need to do now with all the tools that we're being given. We have code written that is going to load documents using text loader. We're going to split these documents into chunks. This is an optimal approach that we need to take for processing the documents that this RAG system is going to use. Then we need to generate the embeddings with OpenAI embeddings and store the chunks and embeddings inside of Chroma DB, the Chroma vector database, via its LangChain integration. One thing to point out are the documents that we're loading. doc1.text, doc2.text. Wow, that should not have been hard to say. I should probably rename these in the future, by the way. Let's go to those files and take a look at what they are. Doc1, doc2, and let me create some room for them. So take a look at what's inside these documents. These are example documents that we want our RAG system to take in and be able to process, like I've mentioned before. So consider this, think about it like the kind of documents that are a part of your knowledge base at the company that you work at, right? If we can ingest that information into our system, then we'll be able to prompt the system to get the answers that we need based off of the information, which is really our data, part of our data, into our system. And this is an example document, company security and compliance guidelines. I wanted to make this somewhat robust and realistic, but no, of course, it's not real company guideline data. This is just something that you can expect an AI, a GenAI system to be fed into, or I guess this is the kind of information that could be fed into a real system in production. The other document are company FAQs, frequently asked questions about the company. So same process, same thing here. This is just text data that we're going to use for our data processing and embedding portion of this tutorial. So in order to start this process, let's just double check the current directory that we're in and the available script files. So these are commands that one could run in the terminal and like with Python, if need be, just to double check, yes, we're in the right directory, and here are the files for the scripts, the Python scripts that we're going to run. The first one is the embedding processor script. We'll take a look at that script after we run the command, but this is for loading, chunking, embedding, and storing in the database. We've got our API key already. We should be good to go. This is a poetry command that will talk to our project and go ahead and run the Python script. And look at the output here. It's looking for documents. It found the documents, and now it's loading and chunking. Oh, it's already done. So that was done in 11 seconds. That's not bad. Successfully created, updated the Chroma vector store. Total items in collection 21. LangChain-based embedding process has been completed. The process has been executed. This is great. Everything's going successfully. I highly encourage you to take a look at the files that were run. You can take a deeper dive by pulling up this Colab and by pulling up the GitHub project on your own. But this was the file that we ran. Embedding processor LangChain. We're using a lot of LangChain tools here to enable this process and really like standardize and make it easier to understand. LangChain handles a lot of this, this entire orchestration for us, and they have partnerships with other tools like our vector store tool, Chroma, so that you can just easily integrate it into your system and build out an actual end-to-end system. So we grab the API key here. We take a look to find our docs that we just looked over for these company guidelines. And then we start loading the documents in. And that is pretty much what's happening here. Splitting the documents into chunks using a text splitter. And once we've done that, we initialize the OpenAI embeddings model via LangChain. You can see that here. The embedding model that was used, if we go up to that constant value, that is a text embedding 3 small. There are other ones as well. This is just what we're using for this example. And of course, there's error handling if something went wrong, wasn't able to load the documents, or no documents were loaded. This is just really good practice with engineering in general to be able to handle errors or any edge cases that could come up. We initialize the Chroma DB vector store via LangChain. We have to find the path, or at least create the path of which we want to create the Chroma directory and files in. And then we need to create the vector store, or the vector store will create embeddings and it will store them there. And that is how we get Chroma DB LangChain. This was not originally part of our project. This was created when we ran that script. And so we see SQLite here and all of this, these files that we won't click on, but this is just a part of how we are creating the system to work for us. And everything works successfully based on this output. Now we can move on to step 4, Ragas evaluation. This is a part of the pipeline, and we want to be able to evaluate what happens when we run this program and prompt a user with questions based on these documents that we have in our system. What is the response that we're going to get? Are these responses going to be going to make sense? Are they going to be hallucinations? This is what allows us to see what the results are. And we want to also be able to measure and quantify, have metrics for these results. And that's what Ragas evaluation helps us to do. Calculating Ragas metrics, context precision, context recall, and faithfulness. We'll dive much deeper into that in other tutorials, but this is just the process of what it takes to be able to run evaluations. So let's go ahead and run that. All right, a lot of output here. We initialized the OpenAI embeddings, chat OpenAI. We're using the GPT 3.5 Turbo model. Switch this out for a different model if you want to. We can dive into that a little bit later. But now let's really look into this. Connecting to Chroma Vector Store from this directory that was generated from the previous script. So we're connecting to the store that has all of the information that we'll need for the LLM to give us a good response. And now we're generating answers and retrieving context using LangChain QA chain. Here is the question and answer process. What is the company's policy on password complexity? The answer is the company's policy is password complexity requires passwords to be at least 12 characters long and include a mix of uppercase letters, lowercase letters, numbers, and special symbols. I mean, this is a really long answer, which could be a really good thing. Retrieved context, it retrieved 3. And this kind of a chain of responses or questions and answers continues a few more times. How should employees report a security incident? Employees should report any suspected or confirmed security incidents such as malware infections, phishing, attempts on unauthorized access, lost or stolen devices. It goes on and on and on. Does the company offer remote work options? We offer remote work options for many positions, XYZ. How can I contact customer support? You can reach our customer support team by emailing. I mean, yeah, these seem like from a high level, if I don't analyze the company policies and security and compliance or FAQs documents that we have stored in the system, just from a high level, it seems like, this is a vibe check, by the way, it seems like everything's good to go. But the wonderful thing about evaluations is that a human in the loop is super important. And so you should be taking a closer look to see if the responses match exactly or close to what the data has been given says, and if these answers are going to be appropriate for responses for someone using this system who does need to rely on actual factual information from company guidelines and frequently asked questions and security and compliance standards, things that you really don't want to miss the mark on when an employee is inquiring about those things. So try to put on like your real life production hat, thinking about how a real user is going to use these systems, and the expectation, use that to shape your expectation around the quality of the responses from this type of RAG system. So take a closer look. I'm going to zoom in at running Ragas evaluation. Here are the results. Context precision 1.0. Context recall 1, and faithfulness 0.9583. Like I said, we'll go into more details about what these evaluation metrics really mean. But this is giving you, these are scores. This evaluation results is saying we feel great about the results of the answers that were given from this system. And those were the metrics that were used, and there are many more. But that whole process for evaluating this RAG system is now complete. You've done it. So one last thing I want you to take a look at is the evaluation LangChain script that we ran as part of the last step. In this script, we are totally focused on evaluation as it implies. We have our same model and our file paths that are set up. We're still checking to make sure that we have the appropriate tools like the API key to get started. And then we're initializing OpenAI embeddings and the LLM through LangChain properties. And everything went smoothly here. Then we connect to the existing Chroma DB vector store, providing the embeddings and targeting the collection name. And then we use LangChain to retrieve our answers. And we create a LangChain retrieval QA chain. So the chain type is stuff. Actually, this puts all the retrieved documents into the context and returns source documents. It's really important for getting the context for evaluations. And so these are just some of the These are just some of the things that you can add to this initialization. And to define the evaluation data set, we want questions and we want truths. So the eval questions are the exact questions that we saw in the list of questions and answers, the Q&A process. There were probably 4 of those. Yes, there are 4 because there's 4 listed for each of these lists, these Python lists here. Here are the eval questions. What is the company's policy on password complexity? How should employees report a security incident? Now, these were all the questions that were asked, and the ground truth is the interesting part to me, is that these are the types of answers that you would want the LLM to respond in those cases. So this gives you the source of truth, or the standard for how the LLM should actually respond when being asked these types of questions. And you can measure against or get an idea of its performance just by setting up an actual standard to measure against. And that's exactly what we did. And we iterate over all of the questions and provide the responses. And so when you run the evaluation and you're using the data, the questions, the context, the ground truth, the source of truth for these questions, and the generated answers, then you can use the Ragas evaluation metrics, context precision, context recall, and faithfulness to actually determine were these decent responses. And that is pretty much it for this intro demo. And don't forget to please check out the GitHub repo, star it, get involved in just exploring this notebook and the lessons that I have here to just enable developers to learn new and exciting things in this AI space. Thank you so much for watching.